This is a satellite foundational course for GOES-R on GOES-R aerosol products that are available in AWIPS. Doctors Kondragunta and Huff are major contributors to this task. I'm Scott Lindstrom from SIMS, and I'll be navigating you through this training. What will you take away from this training? Learning objectives are shown on this page. Aerosol products, boxed in yellow, are just part of the constellation of baseline products shown on this page. GOES-R baseline products are flowing into AWIPS. 3 baseline GOES-R aerosol products are available in AWIPS. Menu items are aerosol detection dust, aerosol detection smoke, and aerosol optical depth. Aerosol detection is available for all 3 sectors, full disk, conus, and meso. Aerosol optical depth, AOD, is available for full disk and conus sectors, but not mesos. The 2 aerosol products complement each other in some ways. Aerosol detection doesn't tell you anything about the amount of aerosols, for example. It simply tells you that certain types, dust or smoke, are present. Aerosol optical depth is a measure of the amount of all aerosols, but it says nothing about the type. Why do you need aerosol detection as available in the AWIPS menu? Aerosols affect the amount of radiation that hits the surface, which in turn will affect, for example, high temperature forecasts. Aerosol detection is important for air quality considerations and air quality forecasts. Many operational numerical models do not as yet include aerosol loading, although there are non-operational models that will predict aerosol motion, and you can find these online. The aerosol products give you information not routinely available in models available in AWIPS. For the purposes of this training, aerosol detection focuses on dust and smoke and haze. Aerosol optical depth, or AOD, measures the extinction, that is to say the attenuation of light, due to scattering and absorption, so it's related to the number of aerosols in the column. As the scattering or absorption increases, because the number of particles in the air increases, AOD will increase. AOD is very low for pristine air with clear skies, but the value can be large, up to near 5 or 6, for thick smoke events. Visibility is definitely linked to AOD and extinction. The inset map shows AOD from MODIS on Terra and Aqua. AOD can be affected by a variety of events, as noted. Here's a summary slide for aerosol products. Aerosol products are created using reflectance values, so they are daytime-only products when solar reflectance is present. They have 2-kilometer resolution. This is the poorest resolution of the reflectance channels, and they're not computed if clouds are present. Aerosol detection occurs every 15 minutes in full disk and conus domains, and every 5 minutes in mesoscale domains. Aerosol optical depth is computed every 15 minutes in the full disk domain and every 5 minutes in the conus domain. It's not computed over mesodomains. Land is pretty reflective at some wavelengths, and that reflectance makes it a bit harder to detect aerosols over land relative to over water. When and where are these products produced? This slide shows that information for Mode 3 domains. Quantitative estimates are limited to solar zenith angles less than 60 degrees, the greenish band in the images of the GOES footprints. A forecaster should be more cautious in using products at high zenith angle, where the results are only qualitative, not quantitative. This figure shows the 2 visible and 4 near-infrared channels on ABI that are used to discern reflectance from the surface and from aerosols. The thin line shows transmittance. Small amounts of scattering and absorption are present in bands 2, 3, 5, and 6, that is the red band at 0.64 micrometers, the veggie band around 0.86 micrometers, the snow ice band around 1.6 micrometers, and the cloud phase band at 2.2 micrometers. The cirrus band, band 4, at 1.38 micrometers, is a region of strong absorption by water vapor, and the blue band, 0.47 micrometers, band 1, is a region of increased scattering. Differences in absorption and scattering by aerosols between all the bands helps the algorithm identify the presence of aerosols. Reflectance changes as a function of both wavelength and surface type, and that complicates aerosol detection over land. Are reflectance differences being driven by surface type, or by the presence of aerosols. Aerosol detection over water is more straightforward. To repeat, the Earth's surface can be highly reflective. Aerosols also affect reflectance in the atmosphere. The trick or challenge is to separate the effect of the surface, not so interesting, from the effect of the atmosphere, much more interesting. The effect of aerosols on reflected visible light varies with wavelength, so the multispectral observing abilities of GOES-R, or in polar orbiting satellites in the visible and the near-infrared, is key. Remember that this is daytime only. Reflectance is driving the observations of aerosols and aerosol optical depth. All visible and near-infrared bands are used with this product. Some infrared bands are used as well, especially with regard to the cloud mask. You can find GOES-16 aerosol products and other products useful for detecting aerosols and smoke at numerous sites online, such as Aerosol Watch. Some of these show data from polar orbiters that don't have the temporal coverage of GOES, but they have higher spatial resolution, especially near the poles. There is also, as of late 2018, a HER smoke modeling effort that can help you anticipate where smoke will be. Here's an example of GOES-16 dust detection over the ocean. This is dust associated with a Saharan air layer outbreak, and GOES-16 aerosol detection captured some, but not all of the event. The split window difference product and the dust RGB, the RGB is shown next, better captured the large horizontal extent of the dust feature. The dust RGB, components are shown on the lower left, can be used to infer the presence of dust. Dust shows up as shades of pink. In this example, the pink is subtle. Over land with dust storms, the pink can be vivid. GOES-16 daytime aerosol detection can find smoke. Some of the spectral tests used in the retrievals are shown on this slide. These mostly include looking at a signal in one band and comparing it to a signal in a different band. Aerosol effects differ at different wavelengths. This is the power of multispectral observations. Here's an example that shows aerosol detection of smoke in AWIPS in the upper right and aerosol optical depth in the upper left. The local satellite zenith angle limit is also showing up in these GOES-16 images from 22 UTC on 9 October 2018. There's a nice correlation, as you might expect, between lots of smoke and high values of AOD. On the following day, smoke detection and large AOD values were far more widespread. The local satellite zenith angle limit is again showing up in these GOES-16 images from 2200 UTC on 10 August 2018. The very high AOD suggests what a potential health hazard this smoke might be if it's at the surface. Satellite detection has to be blended with surface detectors and models to ascertain that. But this smoke would certainly affect high temperature forecasts. Smoke can be very apparent in true color imagery, as shown here. Layer the AOD under the true color and you'll see where the air containing the most particulate matter sits. Aerosol optical depth is very large near where smoke is apparent in the true color. Is there also smoke there? Yes, it becomes apparent later in the day when forward scattering allows it to become more obvious. Along the southern border of this CONUS view, you can see the moving region where AOD is not computed because of the potential for sun glint. AOD and aerosol retrievals are a challenge over very reflective surfaces, especially for dust. So you may see cases where there is obvious dust over land, but little signal in the aerosol products. Some reminders as you use the aerosol baseline products. There are no useful values where it's cloudy, at night, or over bright surfaces. Very thick smoke and dust can be misidentified as cloud, in which case aerosol products aren't computed. Here's where to find more information if you want it. Click on the links. This concludes the GOES-R baseline training on aerosol products. Thanks for your attention.